about the graph theory. Under this graph theory, we discuss about the what is the some definitions about the graph, subgraph, oriented graph, direct graph, and planar graph and the non-planar graph. What is node? What is the loop? And what is tree? And how you draw the tree? And what are the main incidence matrix, how we find out the incidence matrix and reduced incidence matrix, and this we discuss about the what is tie-set matrix and what is the cut-set matrix. So we see some problems under this incidence matrix and the tie-set matrix and a cut-set matrix. So first, when you see in the incidence matrix, when you find out this incidence matrix, first what we do, once again I repeat that, first we have to draw the graph. Okay, so draw graph means, so that is the oriented graph. First, how much nodes must be there, how much branches must be there. So if suppose that will be the one form of the network, so for that network, so you converted in the form of the graph. So the graph will be converted in the form of the line segments. So whatever in between the nodes there is the resistance must be there, simply you have to join between the nodes. If suppose there is the inductive is capacitive, whatever it may be there, just you have to join that nodes. And if there is the voltage source must be there, you have to short, and if there is the current source must be there, you have to open. Already in the given problem they have taken one graph. So in this graph the nodes are A, B, C, D. What is the nodes? A, B, C, D. Node means two or more points meet at an one point is nothing but the node. Okay. Branch means a line segment joined between the two nodes is nothing but the branch. So A, B, C, D are nodes. And what are the branches? 1, 2, 3, 4, 5, 6. So here this one, already the directions are given. Otherwise you have to assume the directions. So here the 1 is connected to A to D, and 4 it will be A to B, and 2 it will be B to D, and 3 it will be connected to D to C, and 5 it will be connected to B to C, and 6 it will be connected to D to C. So when you observe here, so first in this row sides and the column sides I put nodes and branches. Complete instance matrix A, and instance matrix, reduced instance matrix is A. So when you take this side, so how many branches are there in this figure? 6. So 1, 2, 3, 4, 5, 6. And what are the nodes are there? A, B, C and D. A, B, C, D. So when you take for the branch one, so first when you have to consider A node. First we have to consider A node. What are the elements related to the A node? That is 1 and 4. So 1 and 4 will be related. Remaining what are there, that will be put to 0. Remaining will be put to 0. So only 1 and 4 will be considered. So if the elements does not related to that node, put it to 0. Not related to that node, put it to 0. Okay, so here we have to consider that A, that means 1 first branch and fourth branch, first branch and fourth branch, and whatever the 2, 3, 5, 6 will be taken as a 0. 2, 3, 5, 6 will be taken as 0, and 1 will be I put as minus sign, because I already tell that if will be towards the node, put it as minus 1. If it will be the away from the node, put it as 1. Towards the node, minus 1, and away from the node, put it as 1. So when it will be the towards the node, put it as -1, and away from the node, put it as 1. So here 1 is towards the node, put it as -1, and 4 is away from the node, put it as 1. Okay, same thing when you take B. So for the B node, what are the connections? What are the for the B node? What are the elements will be connected? 4, 2, 4, 5. So 2, 4, 5 will be considered, and remaining will be 0. And for the 2 node, it will be entering the 2 node -1, and 4 will be entering to the node -1, and 5 will be leaving to the node. It will be taken as +1. And next C. For the C node, what are the branches will be connected? 3, 5, 6. And 3 is entering to the node, 5 is entering to the node, 6 is entering to the node. So all are -1, -1, -1, and remaining will be 0. Remaining will be 0. And for D, 6th node, D node, there is, what are the branches it will be connected? 1, 2, 3 and 6. 1, 2, 3 and 6. So for this branch, for the D node, 1 is leaving to the node, 2 is leaving to the node, 3 is leaving to the node, 6 is leaving. So all will be put as 1, and remaining will be 0. Remaining will be 0. So if you taken that, when you observe the row, for each row it is -1 + 1, -1 + 1, -1 + 1, -1 + 1. So when you add that all rows, it will becomes to the 0, because one is -1, another is +1, it comes to the 0. Consider the 3 rows. So for the last row you have already right. When it will be the -1, last one it will be 1. When it will be the -1, last one 1. Already -1 is there, last will be 1. When it will be 1 and -1 is there, so I put 0 here. 1 -1 is there, I put 0 is there. -1 only is there, I put 1. So this will be called as complete incidence matrix. Complete incidence matrix. What is incidence matrix is, I have whatever the row must be there, I have to eliminate that will be there, eliminate that one, the last row will be eliminated, then it is called as reduced incidence matrix. Reduced incidence matrix. When I eliminate the last column, then it is called as reduced incidence matrix. Reduced incidence matrix is nothing but the whatever the D I eliminate the D node, then it is called as reduced incidence matrix. Reduced incidence matrix. Okay. Next one, tie-set. What I already tell the what is tie-set and what is cut-set matrix. So tie-set means, so whenever you have to find out the tie-set matrix, first you have to frame the tree. So tree means it will be connect to all the nodes, but it does not form a loop. That is the first thing. And then second thing, whatever the remaining elements must be there, that will be considered as links. And third thing, so for each link there is one loop must be there. If suppose there is 3 links must be there, 3 loops must be there. So for each link there is one loop, and there is for each loop there is one link branches is there, number of tie-sets must be there. For each link there is one link must be there, and there is number of trees must be there. For this tie-set matrix, so in this tie-set matrix, so here there is First we have to consider what is tie branches. That means what are the first you have to consider the tree, and then you consider the remaining elements must be linked. For how many links are there, that is equal to the loops. For each loop, one link must be there and remaining all are tree branches. Only one link must be there, remaining all tree branches. Link direction is same as the loop direction. Link direction is same as the loop direction. So when you consider here, for the link, so for the first loop, that is 4, 5, 6 are links, and 1, 2, 3 are tree branches. So it will be connect all the nodes, but it does not form a loop. So the first, for this loop, there is how many loops are for each link? There is one loop must be there. So for one loop, there is only one link branches are there, remaining are tree branches. So first loop there is 1, 2, 4. So for whatever the link direction is there, first you have to start that direction, and then it will be goes to the 2, and then it goes to 4. And here also there is the second link must be there and third link must be there. So for this, here I have put the branches and tie-sets. Branches and tie-sets. So for first tie-set, that is first loop, so 1, 2, 4 are related, remaining must be 0. 1, 2, 4 are related, remaining must be 0. Why it will be 0 means it does not related to that loop. So we put 4, 3, 5, 6 are 0. So 1, 2, 3, 4 and remaining 3, 5, 6 must be 0. 3, 5, 6 must be 0. So when you observe that for fourth link direction, loop direction must be same. When it will be same, put it as 1. And come to 2, where it will be opposite, put it as -1. For 1, it will be same direction, 1. And 5, it will be for second loop, 5, it will be 1. And for 1, 2, and for the 3, it will be opposite direction, put it as -1. And 2, it will be the same direction, put it as 1. And for this, there is only 3, 6 are related. 3 will be opposite, same direction, 1. That means, so when I consider the link direction, link direction is like 6 is 1 and 3 is -1. So when you observe that, when this problem is correct or not, when you observe that 4, 5, 6, whatever the links must be there, that will be considered as the unit matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1. This is about the tie-set matrix. Next, you have to consider the cut-set matrix. So under the cut-set matrix, same thing you have to follow. First thing, first you have to frame the trees, and then you have to tell that here for each cut set means there is a cut the graph, there is a cut the one part, so you have to cut from that graph. So cut set, for each cut set there is only one tree branch must be there, number of links must be there. So there is, if each cut set only one tree branch, if there is 2 or 3 or whatever the links must be there. So here there is 3 trees are 1, 2, 3. So for each tree branch only one link must, only one tree branch must be there, number of links must be there. But when you have to cut that graph, it will be totally out of that graph. So that will be called as a cut set. So this is the cut set and branches. So the total elements will be 6 and the cut sets are 3. How many tree branches is there? That is equal to the number of cut sets. That is equal to the number of cut sets. So if you take the cut set 1, so the tree branch direction is same as the cut set direction. Is same as the cut set direction. For cut set 1, it will be related to 1 and 4. So 1, 4. So 1 will be the same direction and 4 will be the opposite direction, put it as -1. Remaining it is not related, so put it as 0. Next, go to the B. For B, 2, 4, 5. 2, 4, 5. So, under the 2, 4, 5, 2 will be the same direction, so 1, and 4 will be also same direction, 1, and 5 will be opposite direction, so put it as -1. Same direction, whatever the tree branch direction will be there, we have to put the same directions of the cut sets also. Next, for cut set 3, it will be related 3, 5, 6. So 3 will be the same direction 1, and 5 will be the same 1, and 6 will be the also same. Remaining it does not related, so put it will be 0. Put it will be 0. So here we observe that if the cut sets is right or not, whatever the tree branches must be there, that is 1, 2, 3. These will be the unity matrix. So 1, 2, 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is about the tie-set and cut-set. So tie-set and cut-set, what is the similarity means? We have to first frame the tree branches, and then we have to consider the loops. In this tie-set matrix, how many links must be there? That is equal to the loop. Link direction is same as the loop direction. Next, in the cut-set matrix, you have to take in the tree branches is priority, and that how much of tree branches must be there, that is equal to the number of cut sets. Another problem, that is for the circuit shown, draw the oriented graph and write incidence matrix, tie-set matrix, and fundamental cut-set matrix. See, here the figure is like this. So they have no given the direct graph. Simply they have to given the in terms of resistors, inductors, voltage sources, and current sources must be there. So whatever there must be there. So simply put the nodes and you have to draw the line segments. So how you draw? Simply 1, 2, 3 and 1, 2, 3, 4 are branches, because same thing. When you consider here 1, 2, that here there is the resistor and inductor. So we have to simply draw a line. For this resistor and voltage source, we have to short. Okay. For this, because here there is no consideration of the 6, because I have, if there is a open circuit must be there, so it will be completely open. So there is current source must be there, it will be open. So there is no flow of current in this. So complete 1, these all are in series, 1 and what is the 2 point and 3 point is there. Okay, ending will be 4 point, that is 1, 2 and 3 must be there. So these are in series. So 1 to 2 will be connect, and this will be connected to 1 5 resistor, and from this it will be end to the third point, and here it will be connected to the third point. Like that you have to draw the figure. This is about the, for this you have to draw the incidence matrix. So how you have to draw the incidence matrix? Number of branches are 4 and the number of nodes must be 3. So for this, when you take the first node, 1, 3, 4 will be related. So 2 must be 0. 2 must be 0. And 1 will be towards the node, 3 will be towards the node, and 4 will be away node. When it will be towards the node, put it as -1, -1, and away from the node is 1. And for the second node also, so 2, 3, 4 will be connection. So 2 is away, 3 is away, 4 will be entered. So 4 will be -1 and 2, 3 will be 1, 1. Like that you have to take it as the incidence matrix. When you have to write down the reduced incidence matrix, the third row is to be eliminated. You have to eliminate the third row, then you get the reduced incidence matrix. Then how you write down the tree? So when you have to write down the tree for this circuit, so you have to consider the tree branches. So we have to meet the all nodes, but it does not form a loop. It does not form a loop. So remaining 3 and 4 are links. So when you consider, I am considered this loop, because for each loop, for how many links must be there, that is equal to loop. For each loop there is only one link must be there, number of tie-sets must be there. So this is okay. For 1, 2, 3 must be okay, but the link direction is same as the loop direction. When you consider for this loop, that means 3 and 4 will be link elements must be in the one loop, but both are links. So for each loop there is one link must be there. So already you have to conduct the third loop. You have to go. You have to take in the third element. So first you have to eliminate that element. These 1, 2, 4 must be considered as one loop. 1, 2, 4 must be considered as one loop. So for 3 and 4, 1, 2, 3, 4 branches. For first loop, 1, 2, 3. 1, 2, 3. So link direction will be same 1, and it will be opposite, and 2 will also opposite, -1, -1. And for this loop, that is 1, 2, 4. 1, 2, 4. So 1, 2, 4 link direction will be 1, and the direction of 1 and 2 also same. So you have to put, when you observe that whatever the links must be there, that will be considered as unit matrix 3, 4, 1, 0, 0, 1. Next thing, for drawing the cut-sets. So when you have to, for drawing the cut-sets, how many tree branches must be there? That is equal to the number of cut-sets. For this, there are 2 tree branches must be there. So when you have to cut this graph here, so for each tree branches, there is one tree branch must be there, but number of links must be there for each cut set. So 1, 3, 4 will be one cut set, and 2, 3, 4 will be the another cut set. If branch direction is same as the whatever the cut set direction, that means the branch direction is same as the cut set direction. So put it as 1. If it will be the not same, -1. It will be not related, put it as 0. So first, so when you have to observe that what are the 1, 2 or 3 branches, that will be identity matrix 1, 0, 0, 1. This is about the incidence matrix, tie-set matrix, and cut-set matrix. Next, so when you have to write down these in the form of the network equilibrium equations, or in terms of basis of the loop and the basis of the nodal. KCL means nodal analysis, KVL means loop analysis. So when you have to write down these equations in the loop analysis using graph theory, the minimum number of equilibrium equations required is equal to B minus n minus 1, where B is the number of branches and n is the number of nodes. So here when you have to write down the nodal analysis, the matrix form network equilibrium equation in the form of the loop analysis, in the form of the nodal analysis. So matrix form, incidence matrix KCL is A into IB is equal to 0. KVL VB is equal to A transpose into V into N. Next, for tie-set matrix, IB equal to B transpose IL. For KVL, B into VB is equal to 0. For cut-set matrix, Q into IB equal to 0. VB equal to Q transpose into VT. So, IB means branch currents, IL is the loop current matrix, and VB is the branch voltage matrix, and VT is the twin voltage matrix, and VN is the node voltage matrix. VN is the node voltage matrix. So, for example, write the incidence matrix of the graph. Express branch voltages in terms of the loop voltages. Branch voltage we have to write in the form, up to now we have to consider only the matrix form. Now we have to write down in the form of the equations. Then how you write down? And write tie-set matrix, express branch currents in terms of loop currents. Express branch currents in terms of loop. So this is about the graph they have already given with the terms of the direction. So oriented graph they given, and they have tell that use tree branches are 5, 2, 3, 7. So 5, 2, 3 and 7 must be tree branches. So remaining 4, 6, 1 and 8 are links. So 1 and 8 are links. So this is a 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. How many nodes must be there here? 1, 2, 3, 4, 5 nodes. So in this branch, so when you have to consider the tie-set and cut-set matrix, you have to take in 3 branches or 2, 3, 5, 7. Remaining are links. So for this, when you find out the incidence matrix, so for the 1 will be related to first 1, 5, 8 branches. So 1 is away from the node, 5 is away from the node, 8 is away from the node. So it is minus 1, 1, 1 and the remaining must be 0. Same thing when you have to take 2, it will be 2, 5, 6, 8, 2, 5, 6 will be connected to second node. But 5 will be entering to the node, 6 will be away from the node and 2 will be away from the node. So when 5 will be entering the node, put it as minus 1 and 6 and 2 are 1, 1. Similarly, we take third node. Third will be connected 7, 3, 6 and 8. So here 6 and 8 will be entering to the node, that is minus 1, and 3 and 7 will be leaving to the node, that is plus 1. And for the fourth node, there is 4 and 7 will be connected. 7 will be entering minus 1, 4 will be leaving plus 1. For fifth node, 1, 2, 3, 4 are connected. So all are entering to the fifth node. So all are get minus 1, minus 1, minus 1. So this is about the incidence matrix. So for this incidence matrix, how you write the branch voltages in terms of node voltages. So just you have to be for instant transpose this A matrix. So VB. So how many branches must be there? 8. V1, V2, V3, V4, V5, V6, V7, V8. And A transpose. You have to transpose this matrix. So 1 0 0 0, 0 1 0 0, 0 0 1 0, 0 0 0 1. G 1 minus 1 0 0, 0 1 minus 1 0, 0 0 1 minus 1, 1 0 minus 1 0. And what are the nodes there is will be Vn, that is equal to Vn1, Vn2, Vn3 and Vn4. Vn4. There must be the 4 nodes, because when you have to find out this branch voltages in terms of node voltages, you have to consider reduced incidence matrix. So for the reduced incidence matrix, how many nodes? Vn1, Vn2, Vn3 and Vn4. So like that, for this frag, when you have to write down the tie-set matrix, so they already in the problem they have told 2, 5, 3 and 7 are 3 branches, remaining must be links. So how many loops must be there? For the 4 links, there is 4 loops must be there. Link direction is same as the loop direction. So this is one loop. 1, 2, 5 will be one loop. And 2, 3, 6 will be one loop. 3, 4, 7 will be one loop. And when you observe here, 5, 6, 8, this is one loop. But 6 and 8 are same links. 6 and 8 are same links. So for this 8, we have to consider 8, 2 and 2, 8, 5, 2 and 3. These all will be one loop. You have to eliminate the 6th loop. So when it will be the link direction will be the same as the loop direction. When it will be the same direction, put it as 1. When it will be the opposite, minus 1. It does not equal to 0. So branch currents in terms of loop currents for tie-set, how you write down the equation is IB equal to B transpose IL. So IB is how many branches must be there? I1, I2, I3, I4, I5, I6, I7, I8. And what is the at B transpose? So 1 0 0 0, minus 1 0 minus 1 minus 1 0 minus 1 1 1 0 1 0 0 minus 1 0 0 minus 1 0 0 1 0 0 1 0 0 0 0 0 1 further. And how many what are the links must be there here? Loops must be I loop 1, I loop 2, I loop 3 and I loop. For this equation you have to find out the loop currents. Branch currents will be found in terms of the loop currents. And next one, write down the F cut-set matrix of the graph shown. 1, 2, 3, 4 are tree branches, and write down the equation for fundamental cut-set. So in terms of the nodal KCL, we have to write down the equations. So already you know that for each cut set, that is there is only one tree branches must be there, remaining must be links. So there is for the second branch. So what is the cut set? When you have to cut 1 to 5, there is 2, 1 or 3 branches. So we need not to cut, there is only one tree branch, number of link must be there. So 2, 5, 8 and 7, 6 will be one cut set. And here 5, 3, 6 will be another cut set. For it will be 4, 7, 6 will be one cut set. And for first branch, you have to cut 1, 8, 1, 8, 7, 6 will be the other cut sets. So for that, so 1, 2, 3, 4 are the tree branches. For first cut set is 1, 6, 7, 8. Second cut set is 2, 5, 6, 7, 8. And the third cut set is 3, 5, 6. For the fourth cut set is 4, 6, 7. So you have to write when it will be the cut set direction, tree branch direction will be same. When it will be the same, element direction will be same, then it will be taken as 1. Opposite minus 1. Not related 0. So then how you write down the, how you find the KCL equation in matrix form is QIB is equal to 0. This is the Q. So this is the Q. What is IB? How many number of branches must be there? There is 8. So I1, I2, I3, I4, I5, I6, I7, I8 is equal to 0. So in this class, so you have to find out some problems about the incidence matrix, tie-set matrix, cut-set matrix, and then how you write down the equilibrium, network equilibrium equations to find out the branch currents in terms of the loop currents, that means loop analysis and for nodal analysis. Thank you.